Beware. I see something in the house, but I don't know what it is.
What is something? Q of 2 is equal to the initial value of Q, quantity 1 minus R raised to the power of T. We can substitute Q of T by initial value of Q, 1 minus R raised to the power of T. So the new equation will be initial value of Q, quantity 1 minus R raised to the power of T is equal to initial value of Q all over 2. Since we have to find the percentage or rate of the carbon-14 remained in the fossil, we need to eliminate initial value of Q by dividing. So divide both sides by initial value of Q, cancel the initial value of Q, then 1 minus R raised to the power of T is equal to initial value of Q all over 2 times 1 all over initial value of Q. So cancel. So we remain by 1 minus R raised to the power of T is equal to 1/2. So T is 5,730, which is the half-life of the carbon-14. So 1 minus R raised to the power of 5,730 is equal to 1/2. To eliminate the power of 5,730, we have 5,730th root of quantity 1 minus R raised to the power of 5,730 is equal to 5,730th root of 1/2. So, cancel 5,730. We remain by 1 minus R is equal to 1 all over 5,730th root of 2. Transpose 1 to the other side. R is equal to 1 all over 5,730th root of square root of 2 minus 1. The rate is approximately 1.2096 times 10 raised to the power of -4. Q of 23,100, which is the approximate age of the bone, is equal to K times initial value of Q. We know that Q of 23,100 is just equal to Q of T. From the definition of exponential decay, we have Q of T is equal to initial value of Q, quantity 1 minus R raised to the power of T. Substituting Q of T, we have initial value of Q, quantity 1 minus R raised to the power of T is equal to K times initial value of Q. To get the value of K, divide both sides by initial value of Q. Dividing both sides by initial value of Q, cancel the initial value of Q. We remain by 1 minus R raised to the power of T is equal to K, which the time is equal to 23,100, which is the approximate age of the bone, and the rate is 1.2096 times 10 raised to the power of -4. 1 minus 1.2096 times 10 raised to the power of negative 4 raised to the power of 23,100. K is approximately 0.0612. To get the percentage, we times by 100. 0.0612 times 100 is equal to 6.12. 6% of carbon-14 was remaining in the fossil.